So here in this question, we are given the values of two operators. Operator A is the second derivative operator. It takes the second derivative of whatever function it operates on. Operator B is essentially multiplying any function by x squared. So we need to find out the value of a, b, x cubed. So that will be this, x to the power 5. Now I can write it as I'm going to bring the constant out. And this will give me 20x cubed. So that is the answer. Now let's do the same thing here. This will be x squared multiplying this. So this will be x squared times 3x squared will be, sorry. I only took the first derivative, my bad. So let's actually write it this way. We can do, yeah. So this will be x squared multiplying d over dx of, the first derivative of x cubed is 3x squared. We're going to bring this constant out of the derivative. So 3x squared times that will be 6x cubed. That is the answer. And in this case, we clearly see that it's not, A and B are not commutative, right? We got AB on a function is 20x cubed and BA on a function is 6x. So no, they're not commutative. Now let's do this. This is what we have. So let's so the first derivative of x squared f of x is going to be 2x f of x plus x squared df of x over dx. Now I'm going to bring the constant here out. So the first derivative of x of f of x is going to be 2 times f of x plus x df of x over dx plus and this part is going to be 2x df of x over dx plus x squared second derivative of f of x, right? So yeah, that's fine. So the final value of this is gonna be we have another 2x df of x over dx, right? So when we add it, we get 4x. So I'm just going to do the addition there. And we have x squared d squared f of x over dx squared. Yeah. So the final answer will be 2 times f of x plus 4x d f of x over dx plus x squared d squared f of x over dx squared. That will be the final answer. And as a fun exercise, what you can try doing is replace f of x with x cubed and then see what happens. You got 20x cubed as the answer, right? So here you'll have 2x cubed and here you'll have 4x times Let's actually try plugging it in as a fun exercise. So let's call this equation 1. Now let's have f of x to be x cubed, because that's what we did in part A. In part A, we had a times b operators a, b operating on x cubed. So now let's plug in this value here. So that'll give us 2x cubed plus 4x times the derivative of x cubed is 3x squared plus x squared times the second derivative of x cubed, which will be, the first derivative is 3x squared, so the second derivative is going to be 6x. It will be 2x cubed plus 12x cubed plus 6x cubed. And that will be 20x cubed, which is exactly the answer we got in part A. It's just a fun exercise to try if you are interested. Now let's work on this, which will be x squared multiplying the second derivative of f of x, which is literally just x squared d squared f of x over dx squared. Now, if you want to plug in here, you see clearly that equation 1 is not the same as equation 2. They are widely different, right? So here we have the answer in part B, 6x cubed. So if we have f of x equals x cubed, in this case, it would become, and we know the second derivative of x cubed is actually 6x. 6x cubed. So this is the answer we got in part. So in this case, clearly A and B are not commutative, and this exercise of working out on an actual function x cubed in parts A and B shows us that. And in parts C and D, where we carried out this computation with an arbitrary function f of x, actually gives a more general expression of what happens when these two operators, when you multiply, when the product of these two operators acts on a function. And C and D parts show that these operators are not commutative. They don't give the same result.